Hi, so this video is going to show you how to create some toolpaths for our ShopBot CNC machine. Um, we are going to cut the piece that you see in front of you out of 1/8 inch aluminum. So I'm going to take you through those steps. There are a lot of steps. This is a pretty complicated process. We are trying to get a little drill bit to follow some very precise paths, and it's a high speed drill bit, so there are lots of opportunities for it to break, or for something to go wrong, for someone to get hurt. So we have to be really careful. So I'm going to walk you through the steps. There's also a guide that is going to be published on Canvas that will kind of be a companion to this video. But definitely follow along with the video the first time you're doing this. So I have a body here that I want to cut out. The first thing that I notice is that this body has imported from Onshape in the XZ plane. So I'm kind of looking at the front of it here, and this face in the front should be the top of the object. So the first thing I'm going to do is rotate this down so it fits flat on the XY plane. So I'm going to select body here, and then I'm going to use the move tool. And you can see I have a little grabber here that can rotate it down. Grip that and set that to -90 so it lays flat on the XY plane. And I'm looking at it from the top here. And you can see that I've got the piece. And this is really important so that the CNC knows which direction this is facing. So that's all I really have to do here in my design workspace. I'm going to switch over to my manufacturing workspace to create my toolpaths. So I'm going to click up here on the workspace tab and then go to manufacture. Okay, so this manufacturing workspace offers me a whole bunch of different tools for manufacturing parts. We're going to focus only on a couple of things here, but as you can see, there's a lot going on. The first thing I need to do is create a setup. And so I'm going to click on this new setup tab. This helps me to define my machine, the direction of its axis, and all kinds of things like that. So I'm going to click on setup. And the first thing I'm going to do is select a machine. And so I'm going to click select. And you can see that I already have the Autodesk generic 3-axis CNC mill selected here from a previous job. I'll show you how to find that. If you click on the Fusion library here, you'll see a whole bunch of things. Go over to filters and turn on the milling filter. You can see there are actually a whole bunch of Autodesk generic 3-axis ones. Make sure to find the one that says this machine has XYZ axis on the head. So our ShopBot, the only part that moves is the head of the machine, and it moves both in the X and Y plane, and it also moves up and down. So I'm going to select Autodesk generic 3-axis. This machine has XYZ axis on the head. I'll select that, and it might ask me to download the model if I haven't done this before. Okay, and you can save it in your Fusion. So this will take a second. Okay, and so now I have that selected here. You should see it say Autodesk generic 3-axis. Okay, I'm going to make sure that setup is for milling. That's all we're doing here today. And I am going to keep the orientation at the model orientation. You can see my X, Y, and Z axis. The Z is pointed up, and X and Y are pointed front to back for Y, left to right for X. And for my origin style, I'm going to leave it on stock box point. That's going to allow me to define my origin as some point on my stock. In Fusion, you can see this yellow shaded area. That is the stock. That is the material that I'm cutting out. And there's kind of a default there. We'll fix the stock size in a second. For now, for stock box point, I'm going to click on stock point. And I'd like you to always select the bottom left front corner. So that's that point right there. And you can see the axes. The origin moves over to that bottom left front corner. Then for body, I'll make sure that the body that I want to cut out is selected. And that's all I need to do on this setup tab. Okay, these other fixture definitions. These are for if you have some clamps or something on the machine and you want to define where those are. We're not going to be doing that today. So next I'll move over to my stock tab under setup. And here's where I'm going to define the size of the stock material that I'm using. Under mode, I'm going to use a fixed size box. And before you cut anything, I'd like you to find the stock that you're going to be using to cut. All right, so that might be a piece of aluminum that you need to find in the shop or your team needs to order. It might need to be cut down to size, but we're going to precisely define the sizes of the stock that we actually have. Okay, for this example, I'm going to make my width 6 inches, my depth 6 inches, and this is 1/8 inch high piece of aluminum stock, so 1.125 inches. Okay, so that's the size of the stock. I also need to select where the model sits inside the stock. So the default is center, but you can see we're wasting a lot of material here around the edges of our piece. So I'm going to switch this to X offset from left side. And I'll give myself maybe 1/2 inch from the side. Same thing with Y. So model position offset from front side. And let's give that 0.5 inches. And height, this one's really important. I'm going to offset from the bottom. And the offset should be 0. And that means that the piece is sitting right on the bottom of the stock. Okay, so it should look something like this. You notice that I have left some space around the edges here. We typically want to screw our aluminum pieces, especially because there's a lot of forces involved. We'll put some screws in around the edges of this to hold it down. And I just want to make sure that there's enough space to put a little screw here and to also run my tool around the outside edge. And so I found about 1/2 inch should be good there. When I check your work, that's one thing I'll be checking for to make sure we have a space to screw it down and that there's enough space for the tool to move around that. Okay, but about 1/2 inch. If you want to be a little bit more conservative, you could go up to 3/4 inch of space around on the edges. All right, so I've got my setup done. I've got my stock defined. This all looks good from just a look over. You do not need to worry about part position or post-process in the setups. These are more advanced options. We don't need to mess with these. We're going to go ahead and press OK. Okay, as you can see here that my Autodesk Generic 3-axis printer just popped up here. That's kind of in the way right now. I'm going to go over here to Setup and just click the Hide button there so that that stays out of my way while I'm doing the rest of my work here. Okay, so now next thing we need to do is to find some toolpaths to cut this out. General rule of thumb for cutting toolpaths is you want to work from the smallest to the largest pieces. So we're going to start by cutting these little holes. We're going to use a bore toolpath to cut these holes. Then we'll move on to cutting these interior shapes out using a 2D contour, and then finally we're going to cut around the outside edges. And so that's going to be 3 different cuts that we're going to make. We're actually going to be using 2 different bits for those cuts, and so we're going to be changing the bit kind of in the middle of our job here. Okay, so let's get started with that bore tool. And so all of my cutting patterns are going to be under this 2D menu here. We're not working in 3D here. And I'm going to go down and do a bore. Bore is a circular hole or a circular shape that you're cutting. And so the tool is going to move around in circles as it cuts out. So I'll choose bore, and that's going to bring up my menu here where I can go through the tool, the geometry, the heights, the passes, and the linking tabs here. And so we're going to spend a lot of time in here getting going. For tool, first thing I need to do is figure out the tool I'm going to use. There are really only 2 tools that I'm going to ask you to use on the ShopBot. Okay, one is a 1/4 inch single flute mill bit, and the other is a 1/8 inch single flute mill bit. And And this is a good general purpose tool that works on both plywood and aluminum pretty well. You can import these tools using the library file that is on Canvas. So if you download that library file and you go over here to local and you click on your library and you click import libraries, then you can import libraries from the file that you can download off Canvas, and you'll have these two options. So our 4.5 millimeter holes that we're going to drill are smaller than a 1/4 inch. And so we're going to use the 1/8 inch tool. And we only want to use the 1/8 inch tool if the 1/4 inch tool doesn't work. The 1/8 inch tool needs to go a lot slower. It's a little more fragile, and so we don't work it as hard. The 1/4 inch can move a little quicker, can cut a little deeper, and is a little bit faster moving through the material. But for these holes, we're going to do a 1/8 inch single flute mill. So I'll select that tool, okay, and that pops up on here. I need to go through my speeds and feeds. So this is the most important part of this in terms of safety. We need to set these speeds and feeds correctly so that the drill bit is moving at the right speed to cut the material, and then it's not moving so slow that it's generating a bunch of heat and possibly melting itself to the material, or it's not moving too fast and it actually breaks the bit because it can't cut the material and get it out of the way fast enough. And so we'll take a look. The defaults should be good on these. I've set these tools up so that the defaults are good on aluminum, and they will also work for wood, but you can push wood a little bit faster. So in the guide that I've put on Canvas, you can get the feeds and speeds for different materials. For us, we're only going to set a few of these. We're going to make sure the spindle speed is at 18,000 RPM. Okay, check. We are then going to look at the cutting feed rate. And for my 1/8 inch bit, 55 inches per minute is pretty good, except if I'm cutting a contour. But I'm going to slow this down a bit for a bore, just because it stays in that hole for a long time in one concentrated area, so it might create a lot of heat. So I'm going to just slow this down and make sure that it doesn't cut too aggressively. I'm going to bring this down to 45 inches per minute. You can see that the lead in, lead out, transition, those all updated automatically. I'm going to leave all those. And then my ramp feed rate, I'm going to bump down to 25 inches per minute. Okay, and the plunge feed rate is fine at 1 inch per minute. Okay, so those are all the settings that I need to set for this bore hole pattern. And again, these settings are in the guide, so you can have access to them if you're cutting a different material like plywood. Okay, the next tab I'm going to go to is the geometry tab. So I'm going to skip over the multi-axis. We don't have a multi-axis mill, so I'm going to skip over that, go to geometry. And this is where I select which pieces I want to cut. And so for a bore, it wants me to select circular faces. So I'm going to click on the inside face of each of these holes to tell it where to cut. And so you see it says 4 faces. I don't really need to worry about any of these other tools. It's going to optimize the order. It doesn't really matter for this piece. So I've got those 4 faces selected. Next, I'll go to heights. Okay. There are a couple things I do need to change here. The clearance height and the retract height, the defaults are fine. This is just how high up the tool moves after it's finished with a certain pass, just to keep it out of the way of the stock while it's moving around. The top height for this, since it's just a hole that goes all the way through the material, I'm going to choose stock top with an offset of 0. So that's going to start the hole right at the top of my material. And for bottom height, since these holes go all the way through, I'm going to go to stock bottom, and I'm going to leave a little bit of an offset. I'm going to actually do negative 0.01 inches here. And so that will have the drill bit go slightly below the bottom of the material. It'll go into the spoil board, the MDF board on the CNC machine just a little bit. And that's just to ensure that the hole cuts all the way through. Sometimes the bed's not 100% level, and this will just make sure that it makes it all the way through. Okay, so stock bottom should be negative 0.01. Now I'll move over to my passes. Okay, and this is how many individual circular cuts this makes. When I do a bore, it's a nice efficient cut because it kind of spirals its way down through. If I zoom in on one of these holes, you can see that it creates this spiral, and it goes around and around and around and around and around and around as it cuts. And so you don't want to go too aggressively, too deeply. It should only take off a little bit every circle. And so the setting for that is to disable use ramp angle. And you can see how much this wants to take off per loop. And that's a lot. That's gonna break my bit. So I'm going to set the pitch for aluminum for the 1/8 inch bit. The maximum depth for each circle, each pass is 0.01 inches. So I'm going to set this to 0.01 inches, and that's about as much as it should take off per pass. So disable use ramp angle, set the pitch to 0.01. If I accidentally set this to 0.1, you can see it's going to try to drill through this in like 2 or 3 loops. It's going to break the bit. So I need to just make lots of little passes through this to drill down through. That's the only setting I need to worry about here. If you, for some reason, wanted a really nice clean hole, you could enable multiple passes and finishing passes, and that would kind of drill out the center of the hole and then do a nice clean pass around the outside edge. But we're not going to worry about that right now. We're just going to leave multiple passes and finishing passes unchecked. All right, finally, we'll check on the linking. All of these are fine. When we do our 2D contours, we're definitely going to need to do some of the settings in linking, but the defaults are fine for this bore operation. So I'll click OK, and I am done with defining these holes. And you can see, if I zoom back out, my material, my stock is shown in green, and you can see that once that operation finishes, I will have 4 holes in the corners of this. Last thing I'm going to do once I finish defining a path is I am going to go over to the browser. I'm going to select this path with a right click, and I'm going to click Simulate. And what this is actually going to do is when I press the play button, it's going to actually show the machine's process as it works through this path. And I'm just going to check to make sure it's moving through each place, cutting where it's supposed to cut, and that it's not cutting too deep for each pass. Okay, so you can see, we'll zoom in here and watch as it cuts here. But you can see it's cutting just a little bit at a time, working its way down through. It makes it all the way through. Okay, just cutting a little bit at a time, makes it all the way through, and it'll finish up that last one. If you're using a long operation, you can speed it up a little bit. But this just confirms that everything was programmed as it should. So that's the way the drill bit's going to move around. That all looks great to me. I can exit simulation. All right, let's do a 2D contour to cut out these interior pieces. Okay, so I want to cut out these 5 pockets, and they go all the way through. And that's a perfect operation for what's called a 2D contour. So I'll go back up to the 2D menu, click on 2D contour, and that's going to start a new contour. Okay. For this operation, I am going to switch over to my 1/4 inch bit. These circular radii here or the diameter of these arcs here are 1/4 inch, and I set that up on purpose so I could use my 1/4 inch bit. So I'm going to select Tool. I'll go to my library and I'll find the 1/4 inch bit that I downloaded from Canvas. Select that. Okay, again, we'll go through our feeds and speeds, 18,000 RPM. The cutting feed rate for this, you can see 80 inches per minute. That's faster than we were using with the 1/8 inch bit. So this will cut out a little bit it'll cut out about 30% faster than if I were using the smaller bit. So 80 is good for the cutting feed rate, and that's good for the lead in, lead out, and transition. My ramp feed rate is 50 inches per minute. Okay, that's perfect for this 2D contour, and my plunge feed rate is 10 inches per minute. Ramp and plunge are interesting. Ramp, you saw in the 2D bore, was the kind of an angular cut where it doesn't go plunge down into the material and then cut straight across. Instead, it kind of approaches each cut at a slight angle. And when it's doing that angular move, you want it to slow down a little bit, just to get a nice smooth start and to not stress out the bit too much. Then when it's cutting straight across, it can go up to 80 inches per minute. The plunge, we try to avoid plunges, but every once in a while you have to go straight down into the material. And so this controls how quickly it goes straight down into the material. All right, so these settings are good now. I'll move over to my geometry tab. And here I'm going to select the contours that I want to cut. And so I'm going to just click on the top edge of each of these shapes. You can see it's looking for contiguous shapes here. I'm going to check to make sure that these arrows are on the right side. The arrows showing where the bit is going to move through. I'll show you if something had gone wrong. Say on this contour, you can see the arrow up here. This is showing that the bit is going to move along this path on the outside edge. That is not good because I want it to be cutting this interior portion out. And so if that happens, click on the chain, click on the gear, and click flip directions. Make sure that the red arrows are on the side of the line that you want to be cutting on. All right, so that's our geometry defined. We have an important step here called tabs. And you can see in this little dialog that tabs are little pieces of, let's see if I can bring that up again. Little pieces of material that are left over when you finish cutting. If you can imagine the little circle or the little rectangle of material on the right side, if those little tabs weren't there, as I finished off my cut, that rectangle of material would be completely loose inside of the material and it could come flying out. Remember, there's a 18,000 RPM mill bit in there that is exerting some pretty crazy forces on that. So it needs to be held down in some way. And tabs are a really nice way to hold it down. There is another method for holding it down. We could put some screws through the places in the material where we know we're going to need to hold something down. That takes a little more planning. On the other side, it takes a little less cleaning up. And so that's something we can talk about when you decide to do your cuts. Okay, but we are, for this, going to click on tabs so I can show you, and you can see where those tabs are showing up. The tab width, this is a good tab width for wood, about 1/4 inch. For aluminum, we can make it a little smaller because aluminum is stronger. So we're going to go down to 0.125 inches wide. And our tab height for aluminum, we can make that 0.03 inches. Okay, so I can kind of see where my tabs are. And right now it's set to put a tab about every 2 inches. And so I'm just looking at this and I'm noticing that that looks okay. I'm a little worried about this contour here because there's only one tab holding it, and I could imagine it kind of rocking back and forth in there. So I am going to change my tab distance a little bit. And I've got 2 in there. That makes me more comfortable. At least 2 in every one of these contours. We could also, if you wanted to, select manual tabs and actually go in here and say I didn't like just having 2 here. I wanted to put 1 more up here at the corner. I could click on that and add some. Okay, maybe I'll leave that so we have 3 on this contour. Okay, so you can add manual tabs if you want. Rule of thumb here is just to make sure that there's good solid contact between the material so it doesn't come flying out. Okay, the other options here, rest machining and stock contours, I can ignore for now. I'm going to move over to my heights. Right? In heights, just like in our bore operation, the clearance height and the retract height you can leave at the defaults, and the feed height as well we can leave at the default. What we are concerned about is defining the top of the cut, which is the stock top with an offset of 0 inches, so that's good. Okay, and the bottom right now is at the selected contour. That's not good because the contour we selected was actually on the top of the material. So we're going to go down to stock bottom, and again we're going to give ourselves a negative 1/100th of an inch, negative 0.01 inches offset, so that the bottom of the cut is just a little bit below the bottom of the material, just to make sure we go all the way through. Okay, if I go to kind of a side view here, you can see where the bottom is, where the top is, and where the retract heights are. So kind of just give yourselves a check to make sure that the bottom is at the bottom, just a little bit below, the top's at the top, and the bit's going to be retracting and feeding from higher positions that are not going to get in the way of anything else. So that's our heights. Passes is very important when you're doing contours. We can leave all of these tolerances and finishing things under passes alone. This kind of controls how smooth your final cut's going to be. So there's some things you can do here that take longer in the milling, but it'll give you a better finish. We're gonna skip those for now, but we are going to check multiple depths. The default for this toolpath is to actually cut through this entire material, cut through this entire material in just one pass. And our drill bits just can't handle that, our machine can't handle that. So we want to cut through it at multiple depths. For our aluminum 1/4 inch bit, the maximum roughing step down is going to be 0.02 inches. That is about as deep as we can get that bit into the material before it starts heating up too much. So each pass is about 2/100ths of an inch. And so we're going to go around and around each of these contours about, I don't know, about 6 or 7 times before we cut all the way through it. We don't need a finishing step down. The finishing step down does give you a slightly cleaner bottom edge, but for robotics, I don't think that's super important. If you wanted to experiment with that, you could put one finishing step down on there, but you don't need to. So none of these other settings need to be adjusted. It's just the maximum roughing step down to 0.02 inches. Okay, so that's it on passes. We're going to go to linking, and everything here is fine. Lead-ins tend to give you a little bit of a cleaner cut, so we can leave those on, and we're going to turn on ramp. Again, ramp is that setting where the drill bit will enter the material at a slight angle to take a little bit of pressure off of the mill as it's cutting. And so 2 degrees is good, and you can see the maximum roughing step down automatically set to the maximum step down that I set in the last section. Ramp clearance height, I like to set this to about half of the maximum ramp step down. This is where it starts its ramping operation. You can see in the picture, if it starts too high up, then it's going to go around and around and around that contour without cutting anything. Here, it's going to maybe go halfway around the contour before it kind of reaches the material, and that will take care of any irregularities in the material. Maybe it's a little bit bowed or something like that, where there's a slight raised area, and so we want to keep it out of the way of that. But I found about half of the ramp clearance height is good. If you find that you have a particularly bowed piece of material, especially plywood, and you're having trouble getting it to sit flat, you'd want to set this to a higher value just to keep it well clear of the top of the material when it starts moving down. So that's it for our 2D contour. We'll press OK. You can see it's generating all of these toolpaths. We'll do the same simulation operation. So we'll right click on the toolpath, click simulate, and press play. You can see how it went around about half a time before it got into the material. That was perfect, ramping. And so it's working its way down through the material, taking off 2/100ths of an inch per pass. And so it'll continue around here. I'm just going to finish watching this pass to make sure it makes it all the way through. All right, and you can see that our little tabs are appearing. Okay, and now it's moving on to the second. And so now that I've watched one and I'm pretty happy with it, I'm going to go ahead and speed this up. I do want you to go through and watch the whole thing though. I think it's important just to make sure that you've got a clear picture of how this works. Okay, there we go. Okay, now I'm noticing something here, which I think when I exit the simulation will show up. Look at this weird thing here. So we had that tab, but that tab wasn't actually holding on to any material anyway. It turns out that once this cuts all the way through, there's not much left to prevent from flying out. So actually I'm going to go back in and I'm probably just going to remove both of these tabs. This little bit of material I'm not too worried about causing any damage if it kind of gets ejected from the machine. There's a skirt around the blade that'll catch that. The other ones look fine. This tab in the corner here is not really catching anything, so maybe we'll get rid of this one too. So let's go back and edit that. Show you how to do that. So that's in our geometry, and this was the one that we didn't want to have here. So oops, sorry about that. I'm actually not 100% sure how to delete that tab, except let's go back to 2 inches. So we just have the one here, and maybe we'll just go into manual tabs altogether. And I know how to put one on here, but do we know how to remove one? We'll have to figure that out. If you figure out how to remove the tabs, let me know. We may just need to make the tab distance something really big so none of them show up. And then go in here and add somewhere we know we'll need them, which seems to be on these flattest parts. Once we get into the corners, they seem to want to not be attached anymore. All right. So that's that. Okay, so it's a good example of editing a toolpath. So we edit it, we click OK, it regenerates. I've got a little warning flag here. It says lead out is dropped due to linking constraints. The lead out is that the bit will move a little bit off of the cut as it finishes. Not a big deal. We can ignore that. If you have any questions about a warning, just come see me. And so the last thing we're going to do then is the outline of this. And just a time saver here, I'm going to do another contour operation that goes all the way around this, and I'm going to use all the same settings that I used for the contour on the inside. So rather than going through that whole process again, I'm going to right click on these contours. I'm going to click duplicate. Then I will go in and double click on this to edit it, and all I need to change is my geometry. So I'm going to get rid of these 5 chains, and I will select the outside. And let's go ahead and make my tab distance, well, let's just do manual tabs. I know we want one. Let's put 2 on these long edges and 1 right in the center of these shorter edges. So those tabs look pretty good. That'll keep that locked down. Okay, everything else is set up just fine because I really carefully set the settings for the previous contour. So I'll just press OK, and I'll go through and I will do a quick simulate for that. And it's going to fly around here, ramp its way down. We'll make sure the tabs show up. There they are. And so this is what this piece will look like when it's finished cutting. So I'm removing a lot of material from this, but the tabs you can see are just going to really hold this down. All right, so this is ready to be sent off to the CNC mill. The final thing I need to do is called post-processing, and that is to make sure that, or to convert these toolpaths here from Fusion 360's language into ShopBot language, that's called G code. So I am actually going to show you how to create a post-process document for each of these toolpaths. Sometimes we'll do it for the whole setup if we're confident we're just going to do it in one pass. Since most of you all are new at this, I'd rather you just do one cutting operation at a time, just so if something fails, we're not sitting around or looking at something dangerous for a really long time. So for each of my operations, we'll start with the bore. I'm going to right click. I'm going to click post process. I'm going to find the post option here, and you're going to choose from library. And if you type in the search panel ShopBot, and it's called ShopBot Open, not HandyBot, but ShopBot Open. We'll click that and select. You can copy it to your post processors, that's fine. That'll be in your library from now on. Okay, let's call this bore, and I want to save it to maybe your downloads folder or maybe your desktop. I have a folder on my documents, under my documents for all of my Fusion 360 programs here. So I'll keep it in there. If you're working in metric, you'll want to convert to inches. Our ShopBot likes inches, so convert that to inches. And then I like to update the name of my NC program in the document to bore. Once that's done, I'll press post. It's going to say that it was successfully posted, and under my NC programs here, you can see I have a bore operation. I'll do the same thing for my interior contours. I'll call this interior, change over to my ShopBot, keep it in inches, name it interior down here too. Click post, and then finally post process for the exterior. ShopBot exterior. Okay, so that's all set. Now you're probably wondering what these things are, these NC programs, why we're saving them there in addition to on our computer. So that remember that those files are in my documents folder. Yours are wherever you save them. Say I change something about one of my contours. I don't know, I decided, you know what, I want to have one more tab on this exterior contour. So I'm going to open this up, go to geometry, and I don't know, stick a tab right here. Press OK. Okay, so now my toolpath is set up. I've got that other tab, but you can see here my exterior program is out of date. So the G code does no longer matches the toolpath here. Rather than going through the post-processing again, I can go up here to my NC program. I can right-click on it, and I can click post-process. And it wants to know if it should overwrite my previously written exterior file. Yes, and I'm done. Right, so that just kind of saves the settings for your post-processor so you can resend it if you need to. All right, so that is it. You've got your post-processor files. you can go ahead and send those to ilab3 at avenues-ny.org, and we can get them opened up on the ShopBot computer and get them cut out. So I know that was quite a bit of tutorial, but the steps are really important, and getting everything right is really important. Before you cut anything out, I'm going to ask to look at your Fusion 360. So we'll want to sit down, or better yet, you can send it to me and say, hey, Mr. Carpenter, can you look over my Fusion 360 file, run the simulation, make sure that it is set up correctly, so that when I come in, we can get going on cutting. And just a final note, as you're thinking about cutting things out on the ShopBot, so I'd like you to be there when we are cutting it. Some of these jobs can take a while, and so make sure that you can set aside some time to meet with me to get things cut out. I also really can't cut things during robotic sessions. You know that there are a lot of students there, and not a lot of coaches, and if I have to be standing next to the CNC mill for an hour of a practice, that's a lot of other students that aren't getting any help, and I don't have eyes on what's going on around. So if you do have a CNC project, the best thing to do is to schedule a time to come in the morning when you can meet with me, or come in during an aviator block when the iLab is open. But just reach out to me so we can try to find a time that's going to work for us to get this cut out. All right, that's it for this tutorial. Hope you all have fun getting things set up for the ShopBot, and we can create a lot of cool parts.